Hello mga ka-Johnny! Welcome back to my YouTube channel. This is Sir Robinson Ipulan, your partner in learning mathematics. Before you proceed this video, do not forget to click the subscribe button and give me a thumbs up if my video helps you.
Okay, hello everyone. So welcome back in my YouTube channel. This time we will be solving some problems related to circle. So let's try to solve it using the knowledge that we've learned way back in my previous video and in my class. So let's try to solve this one. I have problem here, problem 1 and problem number 2. In this video, we will be solving these two problems together. Okay, so let's try to solve first problem number 1. So let me show this to you. Okay, there you go. So for problem number 1, ladies and gentlemen, I'll find the equation of the circle that passes through the endpoints of a diameter. So point P, that is 1 and -1, and point Q, that is -5 and -9, and sketch the graph of the circle. Okay, so before we solve this problem, let's get to know the problem first. So what are the given? Of course, we know that what is asked for us is to find the equation of the circle. So every time you are asked to find the equation of the circle, you are simply asked to get the standard form of a circle, or the center radius form of a circle. And do not forget that the center radius form of a circle is in the form of x minus h squared plus y minus k squared is equal to r squared, where h and k is the center of the circle and r is the radius. Okay, so that is the goal. Let's find the standard form of a circle. Second is we will be graphing the circles. Okay, so that is the goal. Find the equation and let's try to graph the circle. So how are we going to do that one? So let's try to know the given here. So what are the given here? So the given here in this problem is the diameter. Okay, the diameter of the circle itself. So in the diameter we have points, or the diameter endpoints. The diameter endpoints here are the point P, that is 1 and -1, and Q, that is -5 and -9. So these are the given, ladies and gentlemen. So of course, if you still remember, how are we going to know the standard form of a circle? First and foremost, we need to know the center of our circle, at the same time the length of our radius. But in the problem, we don't have those things. Okay, so in short, we cannot directly find the standard form of our circle because we need the center, at the same time the radius. But in a given, we only have the endpoints of the diameter. Okay, so how are we going to solve this kind of problem, ladies and gentlemen? So in this problem, let's try to define the diameter itself. Say for example, I have here, let me change the color. Okay, so say for example, I have here the circle. Let's try to draw a circle here, so you can able to visualize what are we trying to say. Okay, so suppose that is a perfect circle, ladies and gentlemen. So when you say diameter, we always define that one twice the radius. Okay, example, this is my radius from the center to any point on the circle. So meaning, again, the radius, that is distance from center to any point on the circle. That's the radius. When you double the radius, ladies and gentlemen, that is what you call the diameter. Okay, this is now our diameter. So this is our diameter, ladies and gentlemen. So this point P and point Q, those are the endpoints. Meaning, those are the endpoints, and that is located the first endpoint here and the second endpoint here. Those are points, ladies and gentlemen. So, in order for us to identify the center of the circle, or in the problem, we need to identify first the center. And we believe once we define the diameter, that is a line segment that passes through the center of the circle and has the endpoints on the circle. So from this problem, we know that the center, or the midpoint of these points P and Q, is automatically the center of the circle. So how are we going to do that one? So in short, we need to find what is the center. Suppose that this is my point P and this is my point Q. We need to identify what is the center of these 2 points. Okay, because after we identify the center of these 2 points, automatically that is the diameter, because the center point of all the diameter is the center of the circle. Okay, so in short, we need to use another thing for us to identify the center of our circle. But before we do that one, let's try to graph this. Point P and point Q, so we can able to really picture out where are these points located. Okay, so let me erase this not so perfect circle here. So wait for a while, ladies and gentlemen. Okay, let me create some Cartesian plane here. So Cartesian plane here. I hope we can have this one as perfect as possible. Positive 1 and negative 1. So most probably this is located on the third quadrant. Okay, so let okay, so here we go. Okay, so let's try to graph point P. So this is now point P, so that is positive 1 and negative 1. So basically this is the location of our point P, that is 1 and negative 1. Okay, how about point Q? So that is negative 5. So that is 1, 2, 3, 4, 5. And negative 9. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I need more space here. There you go. So, and this is the ninth one. Okay, so most probably it is located here. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just making sure that I really counted it right. So this is our point Q. Negative 5 and negative 9. Take note that this point Q and point P is the length of the diameter. Okay, that is the endpoints of our diameter. So let's try to connect these two. There you go. Okay, so that is our diameter. If that is our diameter, so somewhere down here is the center of our circle. So how are we going to know the center of our circle? Of course, we need to use the midpoint of these two. What is the midpoint of this two, or the center of this two? Because the center of this two is the center of the circle. So in order for us to identify the midpoint of our diameter, we need to use the midpoint formula. Okay, what is the midpoint formula? This is the midpoint formula. Midpoint formula. Okay, so the midpoint formula, since we are trying to get the coordinate that is in the form x sub 1 plus x sub 2 all over 2, and y sub 2 for the y coordinate, y sub 1 plus y sub 2 all over 2. Okay, so that is our midpoint formula. We need to find the location of the center of this diameter, ladies and gentlemen. Okay, so let's try to find first they call this one the x variable. Okay, the x variable. So the x or our center x, that is in the form x sub 1 plus x sub 2 all over 2. Okay, what is this x sub 1 and x sub 2? So these are your first x. It could first x and your second x, ladies and gentlemen. Or you can interchange the position. It doesn't matter. Okay, for as long as you know exactly who are your x's. Okay, so let's try to solve this one out. So what is your x sub 1 here? That is positive 1. And what is your x sub 2? Plus, that is negative 5 all over 2. Okay, so if we solve this one out, so it will become negative 4. Negative 4 divided by 2, that is negative 2. Okay, so that is now the x or your h. Okay, that is your h or your x. Let me change this one for you not to confused about it. Okay, so this is your h, okay, or your first term for x. Okay, so that is negative 2. Now let's try to find the k, and that is in the second variable, or the y variable. So that is the form y sub 1 plus y sub 2 all over 2. Okay, so same thing, wherever your x sub 1, so of course the partner should be the y sub 1. So this is your y sub 1 and this is your y sub 2. What are you going to do, ladies and gentlemen? Simply substitute that one in the given formula. Okay, so what are we going to do? What is your y sub 1? That is a negative 1 plus what is your y sub 2? That is negative 9 all over 2. So let's try to simplify this one out. Okay, so let me try move this one upward. Okay, there you go. Okay, so negative 1 plus negative 9, that is negative 10 divided by 2, that is negative 5. Okay, there you go. So we already know our h and k. And then what is our h and k? That is the center of your circle, or in short, that is the center of this diameter. And again, what is the center of of the center of your diameter? That is obviously the center of your circle. So from here we can conclude that therefore the center is, what is your h? That is negative 2. And what is your k? That is negative 5. Okay, so we already have the center of our circle. If we're going to graph this one in this Cartesian plane that we created earlier, so it will become a negative 2, and negative 5. 1, 2, 3, 4, 5. So it is somewhere here. So as you can observe, our line is kinda not that is not straight. So let me correct this diameter. So there you go. Okay, so let's try to connect it again with already we have the center. There you go. So I'm trying to make it as perfect as I can. There you go, ladies and gentlemen. We already graph this center by using the midpoint formula. So automatically this is our center, and that is negative 2 and negative 5. Okay, we already have the center. What did we use again, ladies and gentlemen? We use the midpoint formula. Okay, so in the midpoint formula, automatically that is in the form h and k. Okay, or the center of the circle, ladies and gentlemen. Okay, so we already have the center. So can we solve now the standard form of the circle? No, because we still need the radius of the circle, ladies and gentlemen. How long is the radius of our circle? Okay, let's get to know this one in this side. Okay, so we already have the circle, center rather. So how are we going to identify the radius now? Okay, so as you can observe, this is diameter. And we believe that half of our diameter is the radius. So meaning, this thing here, this one, from a point P to point C, or the point center, that is your radius. And also another radius here, from point C to point P, that is your radius. But we only need radius, and we believe we have the statement that all radii, what is a radii again? That is the plural form for radius. All radii are equal. So meaning, if I'm going to get the distance from point P to point C, and I'm going to get the distance from point C to point P, that is still equal. They are still the same, ladies and gentlemen. So I can use the point Q and point C, or the point C and point P. They are just the same. Okay, so let's try if they are really the same, ladies and gentlemen. Okay, so let me move it down here. There you go. Okay, so let's try to find the distance from point Q, which is what is my point Q, that is negative 5 and negative 9, and the center. What is the center here? The center is negative 2 and negative 5. What is the thing that I'm going to use if I'm going to get the distance of these 2 points? I'm going to use I'm going to use the distance formula. So what is the distance that I'm trying to get? That is the distance of radius. So to find the radius, I need to use the distance formula. Okay, so for the distance formula, that is in the form x sub 2 minus x sub 1 squared plus uh, y sub 2 minus y sub 1 squared. Okay, so same thing, ladies and gentlemen, we are going to use the distance formula, and we have to identify which one is our x sub 1 and which one is our y sub 1. So either you so in my in my points from points Q and point C, for me it doesn't matter if you're gonna choose point C as your x sub 1 and y sub 1, or point Q. It's all up to you. Okay, for as long as you observe consistency. Okay, so here I'm gonna use this one as my x sub 1, or my point Q as my x sub 1 and y sub 1, and my point C is x sub 2 and y sub 2. Okay, so say that's that thing that you're going to use. So let's try to substitute this one out. So what is my x sub 2 here? My x sub 2 is negative 2. Minus what is my x sub 1? My x sub 1 is negative 5. That is raised to the power of 2, plus what is my y sub 2? My y sub 2 here is negative 5, minus what is my y sub 1? My y sub 1 is negative 9. Okay, so we already substituted everything. So let's try to simplify this one. So let's try to simplify, and there you go. So we believe that we have to multiply this negative and negative inside, so it will become positive. So it will become negative 2 plus 5 squared, plus same thing here, negative and negative, that is positive, so it will become negative plus positive 9 squared. And after that, then continue simplifying, ladies and gentlemen. So it will become now negative 2 plus 5, that is positive 3 squared. Positive 3 squared, that is 9. Plus negative 5 plus 9, that is positive 4. 4 squared, that is 16. There you go. That is now 16. Okay, so continue simplifying. Let me erase to really know the space. Okay, there you go. Okay, so from here, 9 plus 16, that is 25. So the square root of 25, so that is 5 units. So therefore, how long is our radius? That is 5 units. Okay, so we, as you can observe here, we tried to find the point C and point Q. So meaning from point C to point Q, that is 5, and automatically that is our radius, because that is the distance from point Q and to our center, where our point Q is the end point of our diameter, and that is located on the circle itself. Okay, let's try if we can really arrive with the same answer if I'm gonna use the point C and point P. Okay, just to confirm it if we got it right. Okay, let's try this one out. So what is my point P? My point P here is positive 1 and negative 1, and my point C here is negative 2 and negative 5, ladies and gentlemen. Let's try same thing. Let's get to know the distance, and that distance is what you call the radius. Okay, the radius of our circle. So let's try to find this one out. So radius is equal to, using the distance formula again, so I can use this one as my x sub 1 and y sub 1. It's all up to you. X sub 2 and y sub 2, for as long as you observe consistency, ladies and gentlemen. Okay, so let's substitute this one out. What is your x sub 2? That is negative 2, minus what is my x sub 1? My x sub 1 here is positive 1 squared, plus what is my y sub 2? That is negative 5, minus what is my y sub 1? That is negative 1 squared. And continue simplifying. Okay, so let's try to simplify it out here. So it will become negative 2 minus 1 squared plus negative 5. So distribute the negative, it will become positive 1 squared. So it will become now negative 3. Negative 2 minus 1, that is negative 3 squared, that is positive 9, plus negative 5 plus 1 is negative 4. Negative 4 squared, that is 16, ladies and gentlemen. So same thing, let's add that one out. So 9 plus 16, that is 25, and the square root of 25 is equal to 5 units. Okay, same thing. If which radius do you want to find, the length or the distance? So same thing here. So meaning we already have the center, we already have the radius. What is our radius here? The radius is 5 units. So meaning from that, all the things or all the important characteristic to find the equation of the circle is already here. So what is the center? -2 and -5. And what is the radius? That is equal to 5 units. Okay, so we are all the things necessary for in finding the standard form is already here. So we can now find the equation of our circle, ladies and gentlemen. Okay, again, just to review before we find the equation of the center, where what did we use in finding the center? We used the midpoint formula because the given is the diameter. How did we get the radius here? We used the distance formula, getting the distance from center to any point of the diameter. Okay, because we believe that the center point or the midpoint of the diameter is automatically the center of the circle. Okay, so from here we already have this one. Can we find the standard form of the circle? Exactly. So again, what is the standard form of the circle here? That is x minus h squared plus y minus k squared is equal to r squared. So let's try to substitute. Automatically, this is your h and this is your k. So how did we find that one? We get the opposite of our, or simply let's substitute this one out here. So it will become wait for a while, this is your x minus what is your h? That is -2 squared plus what, y minus what is your k? That is -5 squared is equal to what is your r? Your r here is 5, so that is 5 squared. Okay, let's try to simplify it a little bit. So it will become x plus 2 squared plus y plus 5 squared is equal to 25. There you go, ladies and gentlemen. That is the standard form of our circle, or the equation of our circle in the given problem number 1. Okay, so are we done? No, because we need to sketch our circle. How big is the circle, ladies and gentlemen? Okay, let's try to graph this one out here. So how did we graph that one? From, let me erase the thing here. So let's try to erase this one out here. Okay, there you go. So let's try to graph this one out. So from the center, how long is the radius? Our radius is 5 units. So we need to count 5 upward, downward, and sidewards. Okay, so 1, 2, 3, 4, 1, 2, 3, 4, 5. There you go. Downward 1, 2, 3, 4, 5. Here. Sideward 1, 2, 3, 4, 5. And other sideward 1, 2, 3, 4, 5. There you go. This is our circle. So let's try to connect this one. So let's make it a little bit perfect to have a better circle here. So let's do this. There you go. So it should pass through the point Q because that is the end point of our diameter. There you go. So it should pass through the point P because that is the end point of our diameter. There you go, ladies and gentlemen. I'm almost done. There you go. So this is now the graph of our circle. Okay, this is now the graph of our circle. What is again the equation of this circle? That is in the form x plus 2 squared plus y plus 5 squared is equal to 25. Okay, that's how we solve problem number 1, ladies and gentlemen. Okay, so again, what is the problem for equation number problem number 1? We need to find the equation of the circle that passes through the endpoints of a diameter. Okay, so that's how we solve it, ladies and gentlemen. Okay, so we are now done with problem number 1. This time, let's try to solve problem number 2 here. Okay, let's try to solve problem number 2. Okay, there you go. Okay, so Same thing with problem number 1. Let's get to know what is asked in our problem and how are we going to solve this one. Of course, this problem revolves around the concept of circle. Okay, so for problem number 2, find the equation of a circle that has the center. So we already have the center. What is the center? That is square root of 5 and 2 and passes through the origin. Sketch the graph of the circle. So the main point of the problem is we need to find the equation of the circle or the standard form of a circle, and we have to graph this one. So how are we going to do that one if we are not really sure with how to do it? Okay, so as you can observe here, I already have the center. My center here is at the point square root of 5 and 2. So I already have the given here. The given in this problem is the center, which is negative 5 and 2. And I have here that my center, it says here that my center passes through the origin. In a Cartesian plane, what is again the origin? That is the center or the intersection of x-axis and y-axis, or that is in the coordinate 0, 0. Okay, so I have a center. I have my center. I have also a point where our circle passes through. Okay, let me present this to you. Let's try to graph this one out. Okay, so I already have this one here. So let me create a Cartesian plane down here. Okay, let's make it a little bit bigger so we can visualize what we are trying to say. Okay, so let me draw. Let's use another color. Okay, so there you go. Okay, so this is how we make it. So first is we graph the circle. The circle is, the center of the circle is the square root of 5 and 2. So let's approximate that one. So you have here 1, 2, and positive 2 here. So square root of 5, if I'm not mistaken, that is approximately 2.24. Okay, that is approximately 2.24. So that is this is positive 1, 2. So approximately it is located down here, if I'm not mistaken. So we are just approximating the value of our square root of 5, and that is here, and positive 2. So basically this is the center. This is the center of our circle. So that is in the point square root of 5 and 2. Okay, the square root of 5 and 2. So it says here that our circle passes through the origin. Where is the origin of our Cartesian plane? Our origin is located here. This is our origin. And that origin, what is the coordinate of origin? That is 0, 0. In short, if we're going to draw a circle here, it passes through here. Okay, so meaning origin is where our origin is located on the circle of this problem. Okay, so if that is located on this circle or on the circle of this problem, in short, the distance of our circle, let me use another color. In short, the distance of our circle to the origin is what you call that is our radius. Okay, again, why did we conclude that that is our radius? Because origin, in this problem, our circle passes through the origin. In short, origin is located on the circle. And we already have the center. And we believe that the distance from center to any point on the circle is what you call the radius. Okay, so automatically the distance of these two is the radius. So we need to find the length of our radius. So in order to find the length of our radius, what thing that we need to use? We need to use the distance formula. Okay, let's use the distance formula. What is again the distance formula, ladies and gentlemen? That is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, what are my points here? I have a point circle, a center rather, that is square root of 5 and 2. And I have the origin. What is the point of the origin? Origin is at 0, 0. Okay, so either way, let's try to substitute. Maybe I'm gonna use this c as my x sub 1 and y sub 1, and the origin is my x sub 2 and y sub 2. Okay, so let's try to substitute it here in our distance formula. So what is my x sub 2? That is 0 minus minus this one. Where is it? X sub 1 is square root of 5. Okay, square root of 5 squared plus what is my y sub 2? That is 0 minus what is my y sub 1? My y sub 1 is positive 2 squared. Okay, keep simplifying, ladies and gentlemen. So meaning, let's try to simplify this one out. So if we're going to simplify this one, so 0, so no value at all. We have value, but any number subtracted to 0 is itself. So it will become here negative 5, negative square root of 5 squared plus negative 2 squared. Okay, continue simplifying, ladies and gentlemen. So from that is, we can conclude that the negative negative raised to the power of 2, that is positive, and we have radical sign here. We can cancel this one out, so it will become only 5 and negative 2 squared, that is positive 4 plus 4 is equal to 5 plus 4, that is 9. Okay, what is the square root of 9? That is 3. Therefore, how long is our radius? That is square root, that is 3 units. Okay, so therefore we already have the radius, we have the center itself. So now we can now find the equation of our circle. It only shows that from origin to this center, the length of that is 3. Okay, that's 3. So we already have the center, we already have the radius. Therefore, we can now solve, or we can now find the distance, or we can now find the standard form, or the equation of our circle. Again, what is the standard form of the equation of the circle? That is x minus h squared plus y minus k squared is equal to r squared. What is my h and k here? The center itself. It is my h and this is my k. So just substitute that one here. It will become x minus what is my h? That is square root of 5 squared plus what is my y? Y minus what is my k? That is 2. So minus 2 squared. And what is my r? My r here is 3. So I have to put 3 squared. And let's try to simplify this one out here. Okay, wait for a while. Let's use color blue. Okay, there you go. So simplify, it will become x minus square root of 5 squared plus y minus 2 squared is equal to 3 squared, that is 9. Therefore, this is now the standard form of this problem, or the equation of our circle. Okay, are we done? No, because we need to graph our circle, ladies and gentlemen. How big is the circle? Considering that we have, how big is the circle? Okay, let's try to graph this one out. So we need to count 3 units from the center itself. This is our center, so let's count 3. 1 2 3. So this is the end point. 1 2 3, another end point. So let's say 1 2 3, another end point here. 1 2, this is a point 24. 1 2 3. So somewhere down here. So we are just approximating, ladies and gentlemen, so let's try to connect this one. Wait. So I think I have the wrong approximation here. Okay, 1 2 1 1 2 and 3, somewhere up here. Okay, so there you go. So let's try to connect these points. So okay, it should pass through the origin. There, I'm almost done. There you go. Okay, so therefore, this is now the circle, the graph of our circle. So we have the equation of x minus the square root of 5 squared plus y minus 2 squared is equal to 9. Okay, so that's how we do it, ladies and gentlemen. So always remember that every time we solve a circle, we have to look for the standard form. We have to stick on the standard form so we can really picture out. We can picture out. Wait for a while. Okay, so these are the things that we solve in this video, ladies and gentlemen. We solved two problems here, given the diameter and given another circle and an endpoint of the circle. I do hope that you've learned a lot in this video. If this video helps you, ladies and gentlemen, do not forget to click the subscribe button. Give me a thumbs up if my video helps you. Again, this is Sir Robin Sanipulan, your partner in learning mathematics. See you in my next video. Bye-bye.